You have here an optimization problem. You could stop the movie and read the question. So, there are practically two different issues here. First is find S in terms of theta and of R. That's itself quite a challenging problem. And then, second part is find the stationary point and determine whether it is a maximum or a minimum. So if we focus on the first part, how to find S. S is, we know, base times height divided by 2. So we have angle BAO is theta and ABO is theta as well. Triangle AOB is isosceles because OB and OA are equal, they are both radii. Therefore, angle BOD is 2 theta, is an exterior angle to the triangle. So see, I'm trying to move to triangle BOD. So in the triangle BOD, we have sine 2 theta is BD over BO, but BO is R. So BD is BO sine 2 theta. In the same triangle, cos 2 theta is OD over BO. So OD is 2R cos 2 theta. Now, the base of the triangle is therefore BC, which is 2 times BD, so it's 4R. Oh, it seems I made a mistake. Why shall I take for BO? BO is R, is not 2R. So these two disappears from here and from here. So BC is then 2R sine 2 theta. And the height of the triangle is AD, which is AO plus OD. So it's R brackets 1 plus cos 2 theta. Therefore, the area of the triangle is BC times AD divided by 2. We cancel a 2 and we get exactly the expression here. We need now to find the value of theta, which makes for which S has a stationary value. I agree that the question is not very clearly formulated here, because it does not state if R depends on theta. So it is assumed that R is a constant. So my variable is theta. To find the stationary point, I need to see where ds by d theta is 0. So R is a constant. How do I differentiate this part here? Is the product rule, right? So we have R squared, and now the derivative of sine 2 theta is cos 2 theta times 2. The second bracket stays as it is, plus, and now we differentiate the bracket, and the derivative of 1 is 0, so we get minus sine 2 theta times 2. Don't forget about the 2 chain rule. Let's make it simpler. We can put in front of a big bracket 2 R squared, and we are left 2R squared. We are left with cos 2 theta. I just want to see if something cancels. Minus plus cos squared 2 theta minus sine squared 2 theta. well, nothing cancels. So stationary points are for ds by d theta equals 0. Therefore, cos 2 theta plus cos squared 2 theta minus sine squared 2 theta equals 0. We have the same angle, is 2 theta, it's okay. Now, we have different trigonometric functions, cos and sine. We want a single one, so we are going to transform sine squared in 1 minus cos squared 2 theta. We cannot transform cos into sine because of this cos here. So my equation is going to be cos 2 theta plus cos squared 2 theta minus 1 plus cos squared 2 theta equals 0. Therefore, so we get a quadratic equation in cos 2 theta, which we can factorize, and we have two solutions for cos 2 theta. Cos 2 theta equals a half, or cos 2 theta equals negative half. The only condition about theta is that it must be between 0 and 90 degrees, or 0 and pi over 2, let us work in radians, because I have that right angle, that isosceles triangle with theta, one of the angles of the basis. So between 0 and pi over 2, cos 2 theta can be just half, cannot be minus half. So from cos 2 theta equals half, I get 2 theta equals cos minus 1 of a half is pi over 3. Therefore, theta equals pi over 6. So in degrees, theta is going to be 30. Now we need to see if it's a minimum or a maximum point. So what we are going to do, we are going to switch our calculators in degrees because it's easier. So we are going to have 30 degrees, 29 degrees, 31 degrees, x, or theta, ds by d theta. So we ds by d theta, and we know that ds by d theta for theta equals 30 degrees equals 0. And we are going to look at the sign here and here, which you are going to do, and then we'll decide, judging by the sign before and after 0, if it's a maximum or a minimum.